Initializing the app router in Next.js 14 is essential for data fetching. Here, we import app router from Next router and create a functional component, MyApp. This component renders the pages component and props. In MyApp, get initial props, we can fetch initial data for our app. This is especially useful for server-side rendering. This setup forms the backbone of our data fetching strategy, allowing us to fetch data either on the server or client side, depending on our requirements. Fetching data on the server side in Next.js is a game changer for SEO and initial load performance. Here, we use getServerSide props to fetch data before our page renders. We call an API, await its response, and then pass the data as props to our page. Notice how we handle the scenario where no data is returned. We return a not found flag. This tells Next.js to render a 404 page. Otherwise, our page component receives the data as props, which we then render. This approach is perfect for pages that need fresh data for each request. Client-side data fetching is crucial for interactive user experiences. In this example, we're using React hooks to fetch data. First, we initialize state for our data, loading status, and any errors. Then, we use useEffect to call our async function fetchData when the component mounts. This function fetches data from an API, updates our state with the result, and handles any errors. We also manage the loading state to provide feedback to the user. If there's an error, we display it, and once the data is loaded, we render it. This pattern ensures a smooth and responsive user experience. Incorporating caching and data fetching can dramatically boost performance. Here, we're using the SWR library, which stands for stale while revalidate. It's a strategy that first returns the data from cache, stale, then sends the fetch request, revalidate. We define a fetcher function to fetch data from our API and use the useSWR hook to make the request. The hook provides us with the data and any error state. If there's an error, we display a fail message. If the data is not yet available, we show a loading indicator. Once the data is fetched, it's displayed on the screen. SWR handles caching, revalidation, and state updates behind the scenes. Data revalidation is a powerful feature for keeping your application's data fresh. In this example, we're using the SWR library for fetching and revalidating user data. The useSWR hook fetches user data based on the user ID and provides a mutate function. This function is used to revalidate the data. If there's an error, we display an error message, and while loading, we show a loading indicator. We also provide a refresh button that calls mutate, triggering a revalidation of the data. This approach ensures the user always sees the most up-to-date information. Handling authentication in data fetching is crucial for secure and personalized user experiences. In this setup, we use SWR for fetching protected data. The fetcher function includes an authorization header using a token retrieved from cookies. This token is used to authenticate the request to our API. If there's an error, it indicates a failure to load the protected data, possibly due to authentication issues. Otherwise, we display the data. This approach ensures that only authenticated users can access sensitive information, maintaining security and user-specific content delivery. Robust error handling is key in any data-driven application. In this example, we're using SWR for data fetching and implementing error handling. When an error occurs during the data fetch, we capture it and display a relevant message. This helps in diagnosing issues quickly. We also handle the loading state, showing a loading message until the data is available. Once the data is loaded, we display it. This pattern of error handling and state management ensures a smooth user experience, providing clear feedback in case of issues and keeping the UI responsive. Optimizing performance in data fetching is about striking the right balance between fresh data and efficient resource usage. Here, we use SWR with specific options to enhance performance. We set deduping interval to 60 seconds, reducing the frequency of data revalidation. This means once the data is fetched, it won't be refetched for another minute, even on multiple renderings. We also disable revalidation on window focus by setting revalidate on focus to false. This reduces unnecessary network requests. Together, these settings help in minimizing the load on both the server and the client, ensuring a more responsive and resource-efficient application. Avoiding common pitfalls in data fetching is crucial for a reliable application. In this example, we're using SWRs on error retry option to smartly handle retries. We set a limit to retry only 3 times, preventing infinite retry loops that can strain the server. We also avoid retrying on 404 errors, as it's unlikely the missing resource will suddenly appear. Additionally, we delay each retry by 5 seconds, giving the server time to recover. These practices help in building a resilient data fetching strategy that can gracefully handle errors without overwhelming the server or degrading the user experience. Incorporating infinite scrolling is a great way to enhance user experience, especially when dealing with large datasets. Here, we use the use swr infinite hook from SWR for seamless data fetching. The hook fetches pages of data based on the index and updates as the user scrolls. We handle the logic to determine if we're reaching the end of our data and if more data is currently being loaded. This prevents unnecessary requests. A load more button is provided for manual fetching, but this can be easily replaced with automatic loading triggers as users scroll. This pattern keeps the interface fluid and responsive, perfect for social media feeds, search results, and more.